so this is going to be the line integral of a function along a smooth curve. So, this is the equation for it. Let's start with an example. So, this problem leans itself well to polar coordinates, so let's start with a circle, okay? So, let's say we wanted to do the integral along a curve of x, y to the fourth ds. Okay. Where C is the right half of the circle. So x squared plus y squared is going to equal 16. So what are we talking about here? We're talking about calculating the line integral of this function, and it's going to consist upon a circle. So if x squared plus y squared equals 16, that means it's going to have a radius of 4, and we're just talking about the right half. So we've got 1, 2, 3, and 4. 1, 2, 3, 4. So this is the line that we're talking about, just the right half of the circle, x squared plus y squared equals 16. Okay. So what are we going to do? We're going to parameterize this problem. Okay. So if we're going to turn this into a parametric equation, what are we going to do? We're going to say, well, x is going to equal 4 cosine of t. And y is going to equal 4 sine of t. Okay. So we're going to change our equation. So we're dealing with this one right here. So the integral of x, y to the fourth ds. And we're going to plug all of our quantities into this, and just remember that x is going to equal 4 cosine t and y is going to equal 4 sine t. So the integral upon this curve. Okay, so now we need to think about, well, how is t changing? If we think about what are the angles that we're dealing with, this is going to rotate from negative pi over 2 all the way to pi over 2. That one encapsulates the full half of that circle. So that's going to go from negative pi over 2 to pi over 2. Okay, so and we're dealing with x, y to the fourth. So we're going to have a 4 cosine of t, that's my x. Okay? And then I'm going to have a 4 sine of t. That's got to be raised to the fourth power, because that's the function that we're dealing with. That's what's defined right there. Okay. And then the square root. Okay, so we have to take the derivative of x with respect to t. So that would be derivative of cosine is negative sine, so that would be negative 4 sine of t squared. And the derivative of sine is cosine, so that would be plus now 4. Now it's a cosine of t squared, and I'm running out of room, but that's dt. Okay, we got a little more room this time. And so that's going to equal the integral from negative pi over 2 to pi over 2. Okay, so we have to think about how many 4s do we have just from the first part. We got a 4 coming from this guy, and then there would be 4 4s coming from this guy, because it's x, y to the 4th. Okay, so 4 times 4 to the 4th power would be 4 to the 5th power times cosine of t times sine to the 4th of t. Okay, so now if I square this guy, well, the negative sign goes away. So we square negatives and they're positive. So that would be 16 now sine squared of t plus 16, okay, now cosine squared of t. And this is still an integral with respect to t. Okay, now, from this we need to, what can we do with this problem? We can say, well, I can pull a 16 out of this component right here, and then what does it become? It becomes sine squared plus cosine squared. Okay? So, that becomes the integral from negative pi over 2 to pi over 2 of 4 to the 5th times cosine of t times sine to the 4th of t. And well, sine squared plus cosine squared equals 1, so this ends up just becoming the square root of 16, which is just going to be another 4. Where we're at this point. And square root of 16 is just 4, so this thing ends up equaling the integral from negative pi over 2 to pi over 2. Now 4 to the 6th times cosine of t and sine to the 4th of t. And this is an integral with respect to t. Okay. Now we have to think about, at this point of the problem, let's harken back all the way to calculus 1 and say, how are we going to actually integrate this thing? Well, this is a U substitution problem. So, I'm going to let U equals sine of t. So the du is going to be cosine of t dt. Cosine of t, cosine of t, dt. Okay? So, remember that when you're doing U substitution, you need to plug your boundaries into your U function. So what is sine of negative pi over 2? Well, that's negative 1. And sine of pi over 2 is positive 1. So this thing ends up becoming the integral from negative 1 to 1. And this becomes 4 to the 6th times u to the 4th du. And so, well, integrating u to the 4th, we just go up by 1 and divide by 1. So this becomes 6 times u to the 5 divided by 5, evaluated at negative 1 and 1. Okay. So that becomes 4 to the 6 divided by 5 times 1 to the 5th, so not minus, and then negative 1 to the 5th. But negative 1 to the 5th power is just negative 1, so 1 minus negative 1 turns into a positive 1. So this thing ends up becoming 4 to the 6 divided by 5 multiplied by 2. Okay? And if we plug that into a calculator, we get that that is 1,638.4. Okay, so that's the line integral of a parametric equation along a smooth curve. Okay, now we're going to try it with just line integrals upon lines, straight lines.